Lesson is 8.4, properties of rhombuses, rectangles, and squares. You know a lot of these shapes, but we're going to go in detail on the properties about them today. First off, we're going to talk about a rhombus. It is a type of parallelogram, and this is the parallelogram symbol. It's a type of parallelogram that has four times you'll hear all congruent sides. It typically looks like this. In which all the sides are congruent. Some people call it a diamond at times. It has nice symmetry. The next shape is a rectangle. That's probably one of the more elementary terms or shapes we're going to be dealing with. There's a standard rectangle. Inside a rectangle, the key fact is that it is a parallelogram. So this is what you need on a rectangle. That's as simple as it gets for a rectangle. It must have those qualities. A square is pretty unique, though. If you look at our poster on the wall, you can see that a square comes from both a rhombus and a rectangle. That means it shares qualities from both shapes. A square typically looks like this. Not exactly like that. We'll say that. It has four right angles and four congruent sides. Example 1 says, for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain. Well, to kind of help you out, they draw sketches for you. But be careful. Whenever you're sketching, make sure that you are labeling correctly. That's kind of like a rhombus. I stretched it out a little too far. But whenever you're labeling a rhombus, RSTV, start out at one corner and go in a clockwise motion. Not really where you start, but make sure you go in a clockwise motion around the shape. If you start mixing it up, then you won't get the question correct. So we'll use this picture to talk about V. Can S be congruent to V? Is it always true on a rhombus that S is congruent to V? Yes, it is true. Can anybody say why? Opposite angles are congruent. Write that phrase out. Opposite angles are congruent. That is the reason why. And today we're going to be dealing a lot with the reasons why things are true. Now the next one talks about T and V. In our picture, can T be congruent to V? Not how it's drawn. Not in this normal rhombus orientation. We called it a square. So on a square, that's like right here, a square, can T be congruent to V? Okay, we got to say why. Okay, because this type of rhombus, a square, is a type of rhombus. With four right angles. That's the clearly explained way why. So this is an always over here. This is always true. That's how a rhombus will always be able to be proven. But will a rhombus always have T and V congruent? No. Only sometimes. True. So we talked about that. We had to jump over to the square. Example 2. pretty easy one. Most everybody's doing really well with this today. Classify the quadrilateral and explain. What kind of shape is that? That's a rhombus. It is a rhombus. So write that down out to the side. And why is it a rhombus? 4 sides. Good job. Try to checkpoint. Checkpoint 1 says for any square CDE. So let's draw that square. It does say, earlier it did say draw it. Usually by drawing it you see it better. On a square, and these are the properties of a square, it is always or sometimes true that CD, up here, is congruent to DE. Is that always or sometimes true? That's always true. And why is it always true? All sides, all 4 sides are congruent. And that's a good answer. Kind of aligns with number 2. You should get a quadrilateral has 4 congruent sides, 4 congruent angles. Classify. Alright, look at the next page. This one has some more detailed properties. These properties are the ones that people miss most frequently. They're definitely more detailed, a little bit more challenging. First one says, a parallelogram is a rhombus if and only if its diagonals are, they cross at an angle, then they are perpendicular. So this is the perpendicular symbol. Perpendicular. Right. Alright, they are perfect. And once again, a rhombus is really nice because it has great symmetry. If you kind of turn it and look at it like a diamond, then you can see that it has nice symmetry. It would create 90-degree angle with its diagonal. 8.12 says a parallelogram is a rhombus if and only if its diagonals bisect the opposite angles. So the key thing that I would focus on is diagonals bisect opposite angles. Diagonals bisect opposite angles. And you can see, once again, it has that nice symmetry. Angles would be divided nicely. It doesn't always work like that on the other shapes. The next one says a parallelogram is a rectangle if and only if its diagonals are congruent. Good job. And that really means that AC is congruent to DD. Little property for that one. Now we're going to use these properties. We're going to really focus on this, and we're going to list everything we know about it. So I'm going to create a new page so we can just focus on this. I don't really like their blanks in this case because we're going to shorthand our properties. This is a rhombus. We got to figure out everything we know about it. Alright, we came up with 7 properties for a rhombus. It has 4 congruent sides. Opposite angles are congruent. Diagonals bisect each other. Opposite sides are parallel. Diagonals are perpendicular. Consecutive angles are supplementary. And the diagonals bisect opposite angles. Now we can go back to our notes and we can look at example 4. Example 4 is one of the most practical problems in the whole chapter. This is a real-life problem. So here's what it says. Building a frame for a painting. The measurements of the frame are shown at the right. The frame must be a rectangle. Given the measurements, can you assume that it is? I'm hearing yeses. I'm hearing yeses. I'm hearing a no. Ding, ding, ding. Paula is correct. This is a no. This is a no. Because we don't know the main property of a rectangle. We don't know what? That the angles are 90 degrees. No, because we don't know what the angle is. Common mistake on this problem is to say yes because it looks like it. If you think of contractors and building constructors, they cannot rely on it's off by just a little bit, and they're creating that little bit is going to be exaggerated. Big method that they will use to check to see if things. How do you think they check to see if they actually have 90-degree angles? They don't have a giant protractor. Anybody know? Yeah. Measure from angles. What are those called? From one angle to its opposite angle. Those are called diagonals. But they measure the diagonals. And they measure diagonals. And if the diagonals are the same, then they know that their structure, or their frame in this case, is square. So, both of them are 25.6. So what could you say? You could say that the frame is a rectangle because they are actually 90 degrees. So the frame is square. I've been saying the term square to describe a 90-degree angle. That's the contractor word saying this is a 90-degree angle. They won't say two walls meet at a 90-degree angle. They'll say the walls are square. So that's why I'm using that term. All right, checkpoint 3 says sketch rectangle W, X, Y, and Z. List everything you know about it. First thing, obviously, from our basic picture, and if you have more marks on it than this, then this is all the marks you should have on a basic rectangle. They make sure that they are 90 degrees. First thing, it has 4 right angles. Another one. Opposite sides congruent. Hold up. Opposite sides are congruent. Are supplementary. Say the good math word, supplementary. Opposite sides parallel. Diagonals do not bisect angles. Diagonals bisect each other. I can write only one at a time. Diagonals bisect each other. Another diagonal one. The diagonals are congruent. Diagonals are congruent. How many is that? That's the 7 that we're looking for a rectangle. Does anybody have any more? This is what you need to help you on your chart, on the test, and on our reviews. So make sure you know these. Good to go.